Hello, my name is Kylie Chandler, and today I'm going to be talking about 11.2, which is patterns and symmetry. Okay, first off, we're going to start with some basic shapes. I'm just going to draw some shapes and then explain their lines of symmetry in those shapes. So the first one we have is going to be a hexagon, which has 6 sides. Not the best artist, so bear with me. Looks good enough. Imagine it's perfectly even and that's a hexagon. And basically when we're drawing the line of symmetry, it's going to be a line that cuts the shape exactly in half. So if you were to fold a piece of paper in half, the shape like along the line, both halves would match equally. So we can look at the shape and say, okay, if we fold it this way, it would be even if it were perfect. I obviously didn't draw it perfect. And then one going this way. And there's going to be one obviously down the middle. And then another one going up and down. And then one here and one here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So those are all the lines of symmetry for a hexagon. It's basically anywhere that you can fold it in half that the sides would match, like if it were a piece of paper. And we're going to use that later on. We're going to use an example to prove that. Next one, just have a, oh goodness, there's a bug. We're going to have a triangle. Looks like this. Imagine it's even because, like I said, I'm not an artist. Now this one, how many times could you fold this one over? It's only got that one line right in the middle that cuts it exactly in half to where if you fold it over, the lines would match evenly. And then there's a triangle that looks like one side's gonna be longer than the other. It's gonna look like this. And actually, this one doesn't fold anyway that it's even, so this one is going to have no lines of symmetry. Yeah, no lines of symmetry on this one since it does not add up. Okay, and then figure D is going to look like this, and then this. I'll make those walls a bit higher actually. This would be a lot easier to explain if I was good at drawing. Okay, so like the other ones before, it's just going to be whatever you can fold along the line that both halves match up easily, or evenly, my bad. And this one only has the one side going down the center. And the last one for these, we're just going to do a basic shape so that we know that we understand the concept. This is lines of symmetry, by the way, so this is the symmetry part. We're going to do a regular triangle. All sides are even. So we're going to have one line down the middle. That's the more proper way to draw the line, but the first one, there were so many, all the arrows would have got confused, so we're just going to use that on the easy ones. Now that's it for the lines of symmetry. Now we're going to use paper to show patterns and basically explain what we say when we're like, if you fold it evenly, then both sides are the same. So if you have a piece of paper and you fold it in half, fold it one time, and you cut this shape in the center of the side that is folded, you're going to open it up and you're going to have a heart. So this one was folded over once, and you cut the shape, and now the shape is on both sides. So both sides are exactly the same, and because of that, it forms a heart in the center. Now, a more difficult one, we're going to take our paper, and instead of folding it once this time, we're going to fold it twice. So you got that first fold it this way, and then we're going to fold it this way. And last time our shape looked like this, but this time we're gonna draw on the side where both sides are folded, we're gonna draw something that looks like this. It's not exactly like the first one, it's more rounded because we folded it an extra time. We're gonna take our scissors, we're gonna cut that shape along the line, and I bet you can guess what it's gonna look like. Would you look at that? Forms a perfect heart on both sides, but instead of being like this time, we folded it twice, so it's going to look like this. Or if you hold it this way, a heart here and a heart here, which basically shows us that pattern, what pattern it would make. It's just an example of like the lines of symmetry showing that basically when it's all unfolded, both sides are going to look the same. So another form of symmetry that we have is rotation symmetry. The best way to describe this is the rotation symmetry of the shape explains that when an object is rotated on its axis, the shape of the object stays the same. And a problem we can use to show this example, there's going to be two parts of this. There's going to be part A and then a part B. Part A is complete the figure shown to give it a 90-degree rotation symmetry about point O. So our point is going to look like this. This type of object. Okay, so this is point O, and we're finding the 90-degree rotation symmetry. Probably need to make more room for that. So we know that a 90-degree angle looks like this. So we're going to rotate this object on its axis to make the shape look the same at a 90-degree angle. So we want this to continue to stay the same, but we're going to make it each different object 90 degrees apart. So we know a 90-degree angle looks like this, so our next line is going to be right here. Then another 90 degrees, I'm going to shift it, make sure it's the same object, so make sure this little flag is pointing this way, and then another 90 degrees, make sure the flag is pointing the right way, and that is rotation symmetry. And then another example of this is going to be the same one, but instead of 90 degree, we're going to do 60 degree. We can also erase that angle. 60 degree rotation symmetry. We know that a 60 degree angle is obviously going to be less than 90, so it's not going to look like the one before. So let's just say it looks something like this. Now we know that this is the 90 degree one, and we know that the 60 degree looks like this. So we have the same point, point O, starts like this. And instead of rotating it at a 90 degree, we're going to rotate it at a 60 degree. So basically, we're going to add another flag in between these. Make sure it faces the same way, about 60 degrees apart. 60 degrees apart. And that is how you do rotation symmetry. So I'm going to review the two definitions that we went over, and then that'll be it for patterns and symmetry. So remember that the line of symmetry is the line that cuts the shape exactly in half. So if you were to fold a shape along a line, if you have a piece of paper and you were to fold a shape along the line, both halves would match exactly, which is the heart example we did, showing it folded once and twice. And then rotation symmetry is the rotation of a shape, which explains that when an object is rotated on its own axis, the shape of the object looks the same. So we see that the object was like this, stayed the same, it just rotated. Same with a 90 degree. Thank you.